In this video, I'm going to show a feature of the 5492B not commonly found on other 5.5-digit multimeters. It is the buffer storage operation. The 5492B can record up to 57 readings per second, which is much faster than you're able to see with your eye. So with the buffer storage, you're able to store those values for analysis after your measurements. The 5492B can store them and then display some math functions like standard deviation, your minimum value, maximum value, and average value. To set up the 5492B to use the buffer storage operation, first we're going to press the Shift menu button. Then we're going to cycle through to the System menu. And this shows the readings stored. So here we're going to tell it that yes, we want to turn that on. So you press the down button, and the left or right buttons will cycle through on and off. So we turn that on and press enter, and it'll say change stored. Next, we need to set the readings count. This is how many readings you want to record, and the 5492B can record up to 512 readings, so I'm going to set it for 512. Once the 5492B is in the buffer storage mode, you're going to see this little asterisk right here underneath the G telling you that it's in that mode. Now the unit is ready to go, and as soon as I press Shift left arrow, the 5492B will start to record. But before we do that, I'm going to show you how I'm going to generate the signal and what we should expect to see. So to generate the waveform that we're going to use to simulate the signal that the 5492B is measuring, I'm going to use this 4045 arbitrary function generator. And to generate the signal, what I've done is I've gone into the Arb menu and clicked Edit, and I went in and added a point that is like an outlier. It's a ramp waveform. And there you'll see in this top little corner there's a little dot, which you might not be able to see here, but I'll show you on the oscilloscope what it's outputting. So here's the signal that I created from the 4045 arbitrary waveform generator. You can see there it's a ramp wave with this little outlier right there, which is about 7 divisions, just over 7 divisions at 1 volt per division, giving us a max value that should be something over 7 volts. So now let's start the recording process. As you'll see now, you're seeing all these readings. It's taking its measurements at 57 readings per second, and the asterisk is lit. As soon as the buffer is full, it will disappear, and we can go in and look at all of the values. So now it has stopped making its measurements, and to view them, you press Shift left arrow, and we will go to System menu again, and go to Saved Readings. So this is reading number 1, and it was measured at 1.255 volts. So this is your standard deviation. It was a 1.11867. Your average was 2.66985 volts. Minimum value was a negative 32.3771 millivolts. And the max value was 7.09573 volts. And that is the little spike that you saw on the oscilloscope screen. To exit this, we do Shift and left arrow, and we're back to doing our normal measurements. So now the data stored in the buffer is in volatile memory. So if you were to power cycle the 5492B, you will lose all of that data. So please remember that. So that is the buffer storage feature of the 5492B. Thank you for watching.